Thanks a lot, Lars. Thanks a lot. It's good to be here. I've been looking forward to it. I've been at this conference a couple of times before, and I think it's a very good conference. I like the organizers, and I like you, the audience, so it's good to be here. So I'll try to concentrate now to tell a little bit about how I think the LNG supplies into Europe in the small and mid-scale will develop. So one thing is sure, I will not be right. It will develop different, but I will try to describe how it could happen. I think I haven't really actually read this one, but I think it says that if I say anything about the future, which is not correct, it's not to be Shell is not to be blamed. Something like that. So. Always important, I think, to remember the basis. It's there are more people coming in the world, and not least there are a lot of poor people and people with low income who will have more income. So the standard of living is increasing, and we think the need for energy will double about up to 2050, so there is really a need for smart people like you and us to find better solutions, because we need energy, and we need energy in a clean and a way that the Earth and we as inhabitants can live with. There's a lot of more of vehicles coming, and there's also things happening in the industry and in the shipping. So it's not really just for fun. It's a duty which sits on us to find good solutions. So in Shell, we think that there will not only, so it would be easy for me to say, since I've been working with LNG for a long time, to say that LNG is the one solution. Well, I think LNG will take a part in the future solutions, at least within shipping and heavy trucking. But I don't think LNG is the only solution for the future.
The world's population is
a mosaic of solutions, and this I will talk a little bit about today. But most of it I will of course not go into. But it's important for LNG, as for other energy solutions, to look at what is the niches which can make best use of LNG. And we think that is the heavy transport users, so like trucking, busing, and shipping. For the energy supply going forward to 2050, it's of course difficult to know how that will happen, but it seems to us that gas will take an important part and an increasing part, maybe a little bit less on oil, as it seems now. And then we have the renewables, we have biomass, and we have wind, which will take increasing parts of the energy supply, as well as solar and probably also nuclear. So maybe the biggest challenge is what will happen here with coal, so that we don't know, but that's we're very depending on to have a good development on the renewables to probably to reduce the use of coal. But it seems that gas will have an increasing part, take an increasing part of the energy supply going forward. So what's normally in gas seen as the three main arguments for gas is that it's abundant. There is supplies for more than 200 years at the current level of use. It's an acceptable, it's not the perfect energy source, because it's still CO2 coming from it, but it burns very clean and it has less CO2, so it's seen as an acceptable energy source, and it's also affordable. So I was hoping now to show a small video just to illustrate a little bit on LNG, how it's made and how it's brought to the market. Some of you might have seen it, others not, but I think it gives them a good overview.
The world's population is growing, and for many, living standards will continue to improve. As a result, global energy demand is expected to double by 2050. To help meet this demand, gas will form an increasingly important role. Natural gas is plentiful, and it's the cleanest burning fossil fuel. But some natural gas resources are in remote locations. Transporting the gas long distances by pipeline can be costly and impractical. The solution? We liquefy the gas by cooling it, which shrinks its volume for easier, economical, and safe transportation by ship. So how is liquefied natural gas produced? Natural gas extracted from the ground contains impurities, water, and other associated liquids. First, it is processed to clean it. It goes through a series of pipes and vessels where gravity helps separate the gas from some of the heavier liquids. Other impurities are then stripped out. The natural gas passes through a water-based solvent that absorbs carbon dioxide and hydrogen sulfide. These would otherwise freeze when the gas is cooled and so cause blockages. Next, any remaining water is removed, as this would also freeze. Finally, remaining lighter natural gas liquids, mainly propane and butane, are extracted to be sold separately or used as a refrigerant later in the cooling process. Traces of mercury are also filtered out. Now the purified natural gas, methane with some ethane, is ready to be liquefied. This happens in heat exchangers. The coolant, chilled by giant refrigerators, absorbs the heat from the natural gas. It cools the gas to minus 162 degrees centigrade, shrinking its volume by 600 times. This turns it into a clear, colorless, non-toxic liquid, liquefied natural gas, or LNG, that is much easier to store and transport. The LNG is kept in insulated tanks until it is ready for loading into a specially designed LNG ship or carrier. Some of the LNG is shipped overseas and regasified to power homes and businesses. LNG for transport is offloaded into separate storage tanks at a midway facility known as a break bulk terminal. Small carriers, supply barges, ferries, cruise liners, container ships, and tankers in ports, on rivers, and in coastal areas. Shell has also helped develop technology to liquefy natural gas on a small scale. This approach uses movable modular liquefaction plants, built in sections to be scaled up or down and potentially moved to another location. The plants can supply transport customers directly, making LNG more accessible. Railroads and tanker trucks carry the LNG to storage tanks at refueling stations for large trucks. Double-walled, vacuum-insulated tanks keep the LNG cool. The pumps and gauges look different, but pumping LNG is like pumping conventional diesel. Compared to conventional diesel, as a transport fuel, LNG has the potential to offer significant fuel cost savings, as well as economic and environmental benefits for operators of large truck fleets and marine vessels. In future, LNG usage may expand into other areas, including rail and mining. Shell believes LNG can help meet the growing energy demand by making more use of natural gas, the cleanest burning fossil fuel. Okay, so I think you agree that it's a way of just illustrating how LNG is made, and so in this illustration you see it starts with the small-scale liquefaction, which we have here in Norway. Not only by Shell, but also other companies have small liquefaction plants, and we bring this to the market, so to bunker vessels, to industry, and also to buses and trucks and so on. You could also take it from, this could also be a large-scale LNG terminal, and you could take it from the large scale and on to a bunker vessel, or you could take it to a depot, regional depot. So I think we will see a variety of solutions in the future, and I'm just using this as a sort of illustration for that. This is here we see Gate as a hub. There are of course also other hubs, but I've just used Gate here.
There is about 20 LNG terminals, big LNG terminals in Europe. So there is quite a lot of LNG available in Europe already. And in this example, I've just put a regional hub in Norway. It could be in UK, it could be in the Baltic, it could be in Germany. So from a large scale, you could take it to a regional hub and then distribute it to the end customers. So I think that is something we will see. We will probably see more small-scale liquefaction like we have a few of, not only in Norway, but also there is also smaller ones in Russia, and in Poland, and so on. But I think maybe we will see, first of all, more LNG coming out of Rotterdam and Zeebrugge and other terminals, and going to larger regional hubs. Norway is not a good example, but it's just easy for me to use because otherwise I have to explain why I put it somewhere else. But there will be in this ECA region and also outside such regional hubs, and from these regional hubs you will see development onto industrial customers as well as bunker locations. So what's the challenge here is to do this in a cost-effective way, because you have to compete with existing fuels, of course, to be competitive. And to do that with the quite expensive logistic cost of LNG, you need to have volume. So when people ask if LNG is available, so I think it's good to be aware that there is a lot of LNG in Europe. It's plentiful available, and there is also enough distribution capacity for much more LNG than is used today in the small and mid-scale. So what you really need is to have concentrations of demand. So that's the only thing. Sort of. There is no logistical barriers today. There is LNG distribution vessels available to take 2 million more tons than what is sold today. So what you need is just concentration of demands. So if a group of industry, if a group of ship owners, if a fleet of ships wants LNG, it's available in Europe. It's just controlled by the end users in a way. But I think to make this happen faster, because it was mentioned from Mikkelsen that development was a bit slower than expected a few years ago, and I think perhaps that one of the things that needs to be looked at is how you can combine use for shipping with other use of energy. That's what can bring forward the speed. It's not really technology, it's not logistics, it's not the molecules, it's just concentrations of users. So it took only 3 years in Norway to develop most of the LNG value chain, which is in operation since. So it was very quick. So once the LNG is there, which it is in Europe, so it's very easy to bring it around. You just need to have concentrations of users. Just some initiatives from our side. Of course, Shell has, like others, we have Skangas here today also, so they have also been early movers, put up money early, and as we read in the papers, not always earning money from the first day, but they have been willing to put up, take risk, as has Shell been doing through Gasnor, and as our Shell are doing now in Rotterdam, putting up a lot of money to make LNG available out of the gate. So that's initiatives which is already made, and you also see a lot of bunkering. There is about, I don't know now, updated it's for 53 vessels, you said, in operation. So that's happening every day, and in the beginning, so we needed a little bit, we had long-term contracts and a lot of negotiation on, on pricing and so on. Today, we can have a phone one day saying he needs one load for a new PSV the next day, and they will probably have it. So market is developing very quickly. It's on the Norwegian coast. This is just a normal commodity. It's not you can get it the next day. We also do bunkering from trucks, of course. We do from bunker depots. Not so much ship to ship yet. We have been doing it, and we know it's done in Stockholm. But up to date, the most usual thing is to take it from fixed depots and from trucks. So here you see bunkering from depot. This is bunkering from truck, and this is ship to ship. We are not doing so much bunkering of the fjord line, but we have done so, and we did it ship to ship from this pioneer nuts. So also worth to note here, this is for LNG for industry at Sunndal, and this is also serves as a regional hub. So Naturgass Møre also it takes LNG out of this hub, and you just need to have some users to get starting. You need to have a concentration of use, and then you are going. And from then on, it's just up to how people to make use of it. So this is started by ferries, but it can of course also be used by trucks and other vessels and so on. So it's just to get it started. Yeah. There's a lot of PSV now going on gas. I'm not sure how many. Anders, do you know? Is it close to 20 PSV now? Not a bit less.
Yeah, close to 20. Yeah, so around there, 15 plus.
Yeah. So this is. I don't think there has been any bad experience on it, and those who built the first ones, they continue to order new ones and so on. There's only good experience with it, and they want to have more of them. So. Yeah. This is from 1912. I think this is the first ocean-going ship using oil. So there was someone then also who started. There was not oil bunkering in all ports when they started, but it didn't take too long time before there were. So so I feel quite confident to say that LNG is today sufficiently available. There's sufficient infrastructure. You can just start, preferably with a concentration of use of, say, in the range of 50,000 tons or something, not one-on-one, but if you have a little bit volume to start with, you can do it all over Europe. So what's special about Shell? Special about Shell is that Shell is in the whole value chain. Shell is one of the biggest producers of LNG and has an annual capacity in its own of about 25 million tons, and then up to what we are doing from truck in Rotterdam and from truck in Norway. So we have the whole value chain. I think there will be also players in the market in the future who will do only part of the value chain, and that can be very interesting. But I think what's a little bit special with us is that gas is now the biggest commodity in Shell. It's bigger than oil. So we will be in the gas business for a really long time. So it's not something we are doing just because DNV is doing it for the next 2 years. This is a long-term commitment, and I think we will also see a lot of cooperation between actors, where there are some are specializing just in the bunker thing, and others are molecule suppliers and so on. But we will try to bring our experience in all parts of the value chain. So this is just for the gate, which will be in operation in 2016, the break bulk, which was mentioned earlier. Let's hope we see that at more LNG terminals in the future, because it helps making LNG available. But already now, it is available. You can take it out of Zeebrugge, you can take it out of gate. It's there. So I think I've mentioned it before, because no, just a lot we have done. I think it's now close to 18,000 bunkerings of LNG. So it's this is without any leaks or mishaps. So it's beginning to get quite some track record. These are the same pictures, and I just wanted to show you the green stream. I also would like to in Rotterdam. Also would like to say that when we talk about LNG, it's important to remember that we are actually talking about gas. It's in the beginning it's LNG. Maybe in 2 years that vessel will have a mixture with biogas. So we already tested on buses in Bergen. We had 8% hydrogen in the buses, and in Sweden they have a mixture of biogas and natural gas. So. And don't forget the PSV from Eidesvik, who they put a fuel cell in the LNG fuel vessel. So, and we also now hear about projects where they use combinations of batteries and gas. So there will be a lot of different solutions in the future. There will not only be the standard LNG tank and an engine. So I think this is just an opening to a lot of creativity to find the most cost-efficient, the cleanest solutions, and I think gas is not the only part of that, but I think it will be an important part of it. Thank you.